Okay, hi everyone. So this video is to show for some of you who might want to explore a more ambitious design and creating a curved ramp without any straight lines. So something like this, which is a good precedent. As you can see, this ramp are all curves or arcs without any straight landings or straight lines. And if we look at the plan, it's pretty much something like this. So we can actually do this pretty easily in CAD. However, compared to what we normally draw in our assignment 1, this one requires much more consideration, sort of pre-planning and calculation. So if we go to the arc tool in CAD, normally we can just draw a random arc with 3 points. But obviously, if we draw it like that, it's sort of hard for us to control and to know the length of the arc. So normally what we suggest you to do is we start looking at a circle first. Because with a circle, you should be able to find out the radius and the arc length quite easily. So remember in Australian Standard 1428, we require that the minimum grading is 1 to 14. So we can normally get a 7-meter long ramp segment for every half-meter drop. So if we we use that as example, and we start with that for all the arc ramp. For instance, if we want to make the ramp segment to be 7 meters, we need to make sure the shortest edge is 7 meters. Okay, so which means that if we offset that one, this is the shortest edge and that's the longest edge. So we need to make sure this particular edge, no matter what radius it is, it needs to sort of comply with the standard. Okay, so now let's have a look how you can calculate the arc length or the radius. So pretty much we know that an arc, you can divide a circle into different sections and divide them into different arcs. So if we look at maybe a semicircle is an arc, or like a quarter of a circle is an arc. So for example, we look at number of arc segments from a circle. So we use that number as n. And if we want to get an arc length which is 7 meters, however, if we want to add the landing, the 7 meter will become 8.2 meters because we require 1.2 minimum for landing distance. Okay, so for this instance, if we take a quarter of the circle as our arc, so we can get C equals 8.2 times 4 equals 32.8. Okay, so we can then reverse calculate the radius of this particular circle, which is 5.22 meters. So now I've got this sort of arc drawn here. Given my drawing is in millimeters, so the dimension is all shown in millimeters. So as you can see, the radius is 5.22 meters, and the arc length here is 8.2 meters, which consists of landings on both ends. So how can we draw this arc? So first of all, if you want to do it really quickly, you can use this particular tool. So we go to arc and we choose start, center, and angle. Okay, so what I do is I specify my, okay, let's do it again. I specify my starting point, okay, which was my arc start. And next point, you can actually type a number to indicate the radius. Say, for example, if I want my radius to be 5.22 meters, so I type. Now, let's start again. So arc, start, center, angle. So starting point, radius, 5220. And angle, so if I want it to be a quarter of a circle, I type in 90. So now I get this particular arc, which is exactly the same length as this one here. But obviously, because I haven't drawn this in like an orthographic sort of limitation, so the angle can be different. Okay, so another way you can draw is actually you draw a guideline first. So you know that the radius is 5 to 20, so you can draw a straight line 5 to 20, and another line here 5 to 20. Okay, and then I can use this tool, so start, center, and end. All right. So again, switch to my arc layer. So start, center, and end. Yeah. So start, center, and end. So you see how it's actually giving me this kind of arc. So actually what we can do is we can reverse our direction. So again, start, center, and end. So that will give me this particular arc. So obviously, you can explore those tools here, but the best way is actually by using the start, center, angle, or start, center, and with the guidelines that's being drawn here. Okay. So now I've got a 8.2 meter long arc. You can always measure the length of the arc by going into the dimension tool. In the drop down menu, there's this arc length, and you can simply select the arc length and drag the dimension out. Okay. Obviously, it's good that when you draft those drawings, you set up multiple layers to sort of make sure that everything is sitting on proper layers. So for my example, I created those, ramp arc and circles and landings and guidelines. So those layers to help me to differentiate all the line work. Because if you get everything sitting on one or two layers, you might get confused later on as there's so many different lines. Okay, so with the radius, you can also come here and choose radius and then get measurement up on the screen. Okay, so now once we get this 8.2 meter arc, okay, let's just copy and paste it here. So if we want to create a 2 meter wide path segment, we can simply choose this arc and we go to offset by 2 meters. So I type in 2000 because it's in millimeters, and then I have to offset that way because I want to make sure this arc is my shortest edge. If I offset it this way, and we measure the arc length here, see how it is sort of only 5 meters long. And if we want to create a 1 to 14 in terms of gradient, this particular path will not comply with Australian standard. Okay, so we need to make sure the offset is on this direction. Okay, so which is what I've got here. Okay, so next, if we copy this and paste it down again. So what I've got next is actually we can sort of get where the path actually ends and the landing start, so on both ends. Okay, so what we do is we want this particular path to be 600 millimeters, so 0.6 meters and 0.6 meters. Same here. So when the next curve ramp joins, that one will also have a 0.6 meter landing. So these two joins together will make it 1.2 meters. So how can we do that? First of all, we can select this arc and we type LEN for lengthen. Okay, so given that I know the total arc length is 8.2 meters, I can change the total length of this, so type T for total. I can change it to, so minus 600 will be 7600, and then I come in here, okay, and then what I can do is I repeat lengthen total and type 7000, and I come into this end. Okay, so I do the same for this one. So lengthen total. So now this one is 11341. So I type in 10741, and again lengthen total 10141. Okay, so actually now if I copy these guys again, so I do this just to make sure that you understand the process. Okay, so the green ones actually have landings on both ends, and the orange layer does not. Orange layer only has a ramp segment. Okay, so what I can do is so if you guys see how this is the ramp, and this is the ramp segment with landings at the end. So what I can do now is if I switch to the landing layer and come to polylines and can click connect those endpoints together, so you know where my landing starts and finish. Okay, so pretty much this is how we can draft a curved landing segment. Obviously, you can have different radius, you can have different arc length, you can have different sort of angles. Say, for example, this one is more of a semicircular segment, and this one is actually 3/4 of a circle. Okay, so basically what you can do is you can actually draw everything on paper first, and have a sort of overall plan on how you want to shape your terrain and how you want to lay out your path in terms of connecting to the house and the existing path. Okay, so what I've done here is actually I've also created a longer segment, which is 40 meters to represent a 1 to 80 walkway, or like a 1 to 40 walkway if it's across a 1 meter drop. Okay, so obviously the method is the same. All right, so if I want to sort of join this one here and that one, what should I do? So obviously what you can do is by coming in here. Okay, so let's just copy this one. Okay, I'll sort of come up here and show you guys, and I'll copy that one there. So now I've got those 4 different segments sitting here. So my purpose is actually to join them together to create something like this. Okay, so the first step is actually we basically use simple rotation and move tool to do that. So first of all, if we want to join this guy to this guy here, I can just move this over, okay, and I'll actually move by snapping to this point. So make sure your snap endpoint is on, okay, and then to this particular endpoint, okay, and then I'll choose this one again. So what happens is I need to rotate this one here. So by the look of it, I can actually rotate by 90 degrees right away, but actually we'll use the reference rotation for this time. So I type rotate, and here is my reference point, and then I'll type R for reference. So I click this point again, and I want to use this one as my secondary reference point, and then I rotate over until these two endpoints meet each other, okay? And then now I want to have this end bit here. So what I do again, I move it over here, so make sure this point snap to this endpoint, and rotate, reference point R, and this point here, and rotate. So these two meet together. So same thing, if I move this down a bit more to have a bit more room. Okay, so again, I'll have to choose this one, and then move it down. So that is actually, so maybe I won't sort of move too close. I might just rotate it a bit first. So roughly there, and then I move it across. Here. So rotate, reference point R, this point until they meet. Okay, now so I've roughly got this ramp joined together. So now I've got this ramp finished. So I'm just pretending that's all the ramp segments I will need. What I will do is I will need to separate the ramp segment and the landings, because right now there's some overlapping happening. Okay, so what I do is I would isolate my landing layer by typing lay ISO, and then I'll use my trim tool to trim off all those lines that actually are ramp segments. Okay, so here obviously there's something that's not meeting up properly. So again, I will trim off all these ones. Okay, and bring back my ramp segment. So now we've got this nice base drawing for all my ramp segments and my landings, which is exactly the same as this one here. Okay, and next we need to figure out tracing the outline to be able to take that into 3ds Max and do bevel or extrusion. So in my previous video on the curve landings, I've actually shown you guys how to do that. So when we trace the outline of the path, we need to make sure all the grid edit points are clicked in CAD. So when we bring them into 3ds Max, there won't be any issues. The tricky thing about Arc is sometimes the center point has been, when you click it, it's still a center point, not a control point. So if we go through that now, so I use my polyline tool, so I click these two endpoints, and then I say for the options down here, I type A for arc and second point, so I type S. So normally I use the center point as my second point, and then coming to the end of my arc. Okay, and I do S again for the landing, so second point, which is the center point of this arc, and end here, and S again, center point, and end of arc. Okay, so let's stop here for now. If I isolate my outline, so you see these two control points are fine, but however here, the center of the arc, it's only a center point, not a control point. So we need to change that here, right, in order to make it work properly. So in order to make sure that all control points are clicked and imported into 3ds Max, so what I've done is actually by further separating the arc into 4 different sections. So 1, 2, 3, 4. And I've drawn those guidelines to make that happen. So, okay, so what I'll do is here, I switch to my guideline layer, right? And I use the polyline, just draw straight lines. So endpoint to center point to endpoint, okay? And then I use this center point to draw a perpendicular line covering both of my arcs, so this one and that one, okay? So if you want to make sure that your line drawing is perpendicular, you can also type PERP, perp, so polyline, and type PERP, and you see how this symbol appears when you click that. Okay, so same here, center line and perpendicular. So alternatively, you can just make sure that the perpendicular snap is on. So I do this for all my wrap segment. Okay, center line and to end point, center, perpendicular, center, perpendicular. Okay, so I won't go through everything, but you will pretty much end up with something like that. Okay, so once I've got that, I can then switch back to my outline layer. I'll start trace again. Okay, so click, and then come to my arc. Again, second point. So now instead of choosing this one as my second point, I'll go for here, which is the intersection, okay, and endpoint here, which is this intersection. All right, and then I go for second point, so intersection, and here. So for landings, normally it's okay because you've got this point here anyway. So okay. And there, and there. Okay, down here, second point. And here, second point. And here. Okay, so again, I won't go through the whole thing, but you pretty much end up tracing the whole wrap, and you end up with this particular outline, which shows the center point as control point. Okay, center point as control point, here as well, here as well. And once you import this entire outline into 3ds Max, everything will work nicely and you'll be able to do extrusion, bevels, or booleans. So hopefully you actually learned something from this tutorial. It's not a compulsory, you need to do this. I just for someone that who might be interested in exploring this option and incorporate that into your design. Thank you guys.